Hello students, today we are going to discuss the range of a function. First of all, we must be very clear what is range. If y equal to fx be a function, then range of f, this is symbol for range of f, is a set of values of y when x belong to the domain. This means to find out the range, we must know the domain of the function. Let us see some illustrative examples. We start with a very simple example, fx equal to 1 by x. We'll try to find the range of this function. So as we have written set of values of y when x belong to domain, it is very easy to identify what is domain of this function. It's all real numbers except 0, because we know that if we substitute 0 at the denominator, this function will be undefined quantity. So therefore, from the domain we have to erase out the value 0. Now next thing is finding out the range. The very first step to find out the range, we have to introduce the variable y. We have written y equal to 1 by x. So this implies x equal to 1 upon y. And it is always this method we try to express x in terms of y. Now if we recall the definition of range, set of values of y when x belong to domain, so we have to refer when x will belong to df domain, then y would belong to all real number except 0, because domain happens to be a real number except 0. So if x has to be a real number, the y has to be a non-zero real number. So therefore we can conclude a range equal to all real numbers except 0. So this is the answer to our first example. The range of 1 by x is equal to all real number except 0. Next example, fx equal to 1 by x minus 1. In this case, we can very easily write down domain equal to all real numbers except 1, because denominator में x cannot take the value 1. To find range, we write down y equal to 1 by x minus 1, and now our effort is to express y in terms of x. So this implies your x equal to 1 plus 1 by y, so y plus 1 upon y. So this is the expression of x in terms of y. So now we write down when x belong to domain, that means x is a real number except 1. So in that case y would belong to all non-zero real numbers are except 0. So therefore in this case also our range is all real numbers except 0. So one thing you should remember, whenever the function is a rational function, then the range is always all real number except 0. Always in the sense that when the function is rational and the denominator is a linear term, in that case 1 by a linear expression, because in case of quadratic expression the range will be different, but in case of 1 by linear expression, then the range is always all real numbers except 0. Next question, find the range of fx equal to 1 by x square minus 1. In this case, well ahead we can recognize the domain as all real numbers except minus 2 and 2. This is the domain, right? To find range, what we are supposed to do, y equal to 1 by x square minus 4. We try to express x in terms of y, so we bring this to this side, x square minus 4 equal to 1 by y. So this would imply x square is equal to 4 plus 1 upon y. So 4y plus y equal to y. So now we have to consider some cases, because you see x square is coming out to be 4y plus 1 by y. And what is x? When x belong to domain, x is a real number except minus 2 and 2, but x is a real number. So when x will belong to domain, x square will be greater than or equal to 0, because the square of a real number is always non-negative, which will make it 4y plus 1 by y greater than or equal to 0. We have to just replace this x square by the above obtained term. So 4y plus 1 by y is greater than or equal to 0. Now let us think about this case. Which case? This case. This is division of two quantities. One is in the numerator, one is in the denominator. And we know that division of these two quantities is positive, or you can say non-negative, if both are positive or both are negative. So we have to consider two cases now. And this is the first case where we have taken both positive, right? Here also greater than or equal to 0, denominator also greater than 0, because equal to 0 in the denominator we cannot take, because if denominator is equal to 0, then this function will be non-defined quantity, right? Something by 0 is undefined. So from this we can write down, from this inequality, 4y greater than or equal to minus 1, this implies y is greater than or equal to minus 1 by 4. From this inequality, what is there? Y is greater than 0. Now you see, we have to take combination of these two cases, common region of both the case, because in this case what we'll have, here we have 0 is a whole circle we have to use, because 0 is it is strictly greater than 0. So this region will be represented by y strictly greater than 0. And minus 4 mein we have to use a bold circle. Here we use a hollow circle, bold circle. So y is greater than minus 1 by 4 matlab this region. So what is the common of both of them? This y greater than 0 is common of both of them. So the output of case 1 will come out as y is greater than 0, which is combination of both. Y is greater than 0 matlab y belong to 0 to infinity. So this is the region for y, or you can say this is the range for y for the case 1 when we have considered both positive. Now we have to consider both negative. And here we have taken case 2, 4y plus 1 less than or equal to 0, y is strictly less than 0, because y happens to be at the denominator. Now from this case, 4y plus 1 strictly less than or equal to 0, so we get y is less than minus 1 by 4. That means that case is this case, y is less than minus 1 by 4 matlab on the left side of the real line, number line, okay? And y is strictly less than 0 matlab this case. So what is the combination of both? To common region of both this case is y is less than or equal to minus 1 by 4. So this implies y belong to minus infinity to minus 1 by 4. So this is a output of case 2 and this is the output of case 1. So combination of these two, we can write down the range as minus infinity to minus 1 by 4. Here it is closed interval, union 0 to infinity, and this is the required range of the given function. Hope you understand this. Next example, find the range of 1 by 9 minus x square. Here we have identified the domain first. The domain is all real numbers except minus 3 and 3. Now next step is to find the range. We have introduced the new variable y here, because range means set of values of y when x belong to domain. Now the next effort is to express x in terms of y, that is 9y minus 1 upon y. So this is your x square in terms of y. Again going back to the definition of range, set of values of y when x belong to domain. So here we'll write down when x belong to domain, this implies x square will be greater than equal to 0. So this implies 9y minus 1 by y greater than equal to 0. Like in the previous case, here also now it is a time for considering two cases. Case 1. Case 1 mein what we have to take? Both are positive. That means 9y minus 1 is greater than equal to 0 and y is strictly greater than 0, and this leads to y greater than equal to 1 by 9 and y greater than 0, and the combination of these two will be equal to y greater than equal to 1 by 9. That means y belong to 1 by 9 to infinity. Next we have to consider case 2. In the second case we have considered both are negative, so the common case is y is strictly less than 0. That means y belongs to minus infinity to 0. So eventually the answer is minus infinity to 0 union 1 by 9 to infinity. So this is the required range of the function. Question number 5. Find the range of 1 by 1 plus x square. So straight away we can say that the domain is R, because we can see denominator में no issue case. Denominator can never be 0 whatever you put for x. So to find range we have introduced y. So x square equal to 1 minus 1 by y minus 1. So therefore x square equal to 1 minus y upon y. So we have expressed x square in terms of y. Now we know that when x belong to domain, so when x belong to domain, so this would imply your x square is greater than equal to 0. So this would imply 1 minus y by y greater than equal to 0. Now again we have to consider two cases like in the previous question. So this is the first case where both are positive. 1 minus y greater than equal to 0, y greater than 0. So y is less than 1 and y greater than 0. So y is greater than 0 but less than equal to 1. So y will belong to 0 to 1. This is case 1. In the second case, we have taken both negative. So it will give us कि y is more than 1 but less than 0. How it is possible कि number could be more than 0 and less than 1? So how is it possible कि number is more than 1 but less than 0? Therefore in this case y will belong to phi, because we cannot have a common region. So combination of these two we can write down the range is from 0 to 1, and this is the actually the required answer. The range is going from 0 to 1. Example 6. Find the range of x by 1 plus x square. Straight away domain is R. Domain में कोई issue है ही नहीं, because denominator में whatever you put for x, it cannot be equal to 0. To find range, what we have to do? Introduce the y, which is x by 1 plus x square. Next step is now we have to try to express it is y plus yx square minus x equal to 0. Here it will not be possible to express x in terms of y, so our method will be slightly different now. We have written this equation as a quadratic in x. This we have written in quadratic in x. Now when x will belong to domain, when x belong to domain, and domain means what? That is x belong to set of real number R. So when x is real, in this example if x is real, that means discriminant of this should be greater than equal to 0. So therefore minus 1 b square minus 4ac greater than equal to 0, because x is a real number. So discriminant should be greater than equal to 0, and this leads to 1 greater than equal to 4y square, and this leads to y square is less than equal to 1 by 4, right? So this leads to y square is less than equal to 1 by 2 whole square. and it is a famous inequality when x square is less than a square. That means x is in between minus a and a. So in this case 1 by 2 less than y less than 1 by 2. So this means in this case y will belong to minus half and half. So therefore a range will be minus half to half. This is the required range for this function, minus half to half. Hope you understand this example. Example number 7. Fx equal to x square by 1 plus x square. So straight away domain equal to all real number r, right? To find range, we have introduced y and trying to express x in terms of y, and we reached up to x square is equal to y by 1 plus y. Again the same phenomena, when x will belong to domain, so x square will be greater than equal to 0. So in that case y upon 1 minus y greater than equal to 0. Again the two cases will be generated now, case 1 and case 2. From the first case we get this solution, that is when numerator is greater than equal to 0, denominator cannot be equal to but strictly greater than 0. So y lies between 0 and 1. Now case 2. From case 2 we are getting y less than equal to 0, y more than 1, so I belong to phi. So combination of these two will give us y belong to 0 to 1 union phi, which is equal to 0 to 1 only. So therefore the required range for this function is 0 to 1, and this is the required solution of the given question. The range of this function is from 0 to 1.